Just good afternoon all. So now we discuss third unit. This is the life cycle of phases and artifacts of the process and model based software architecture. Okay. See, the characteristics of a successful software development process is well defined separation between the research and development activities and the production activities. So most unsuccessful projects exhibit one of the following characteristics, that is an overemphasis on research and development, on production, and successful modern projects and even successful projects developed under the conventional process tend to have a very well defined project milestones when there is a noticeable transition from a research attitude to a production attitude. Okay, so whenever you have to give the successful of the characteristics of software development process is the separation between the research and development and the product. So it may be different to the research and development and the productions. Okay, and a modern software development process must be defined to support the following process. The first one is the evolution of the plans, requirements and architecture, and together with well defined synchronization points. So risk management and objective measures of progress and quality, and evaluation of system capabilities through the demonstration of increasing the functionality. So whenever we have to implement that software development as SDP, it is the main thing of the evolution of the plans, requirements and architecture, and together with the different of the synchronization points, and based upon the risk management and objective measures also it will be defined the progression of the quality and the evolution of system capabilities through demonstration of increasing functionalities. Okay. Next one, see, engineering and production stages, that is the to achieve economical of scale and higher returns on the investment, that is ROI, we must move toward a software manufacturing processes. So driven by the technological improvements in the process automation and component based development. So in second unit we have discussed on the what is mean component based and what are the automation tools we have to using for the particular processing. Okay, so here we can implement the two stages, that is the engineering and production stage. See, the engineering stage driven by less predictable but smaller teams doing design and synthesis activities. In the engineering stage, smaller teams will be doing the subset of the processes. Okay, there is but smaller teams doing design and synthesis activities. In going to the production stage, they're driven by more predictable but large teams doing constructions, testing and development activities. Okay, in the engineering stage, some of the teams go for the design and synthesis activities and go for the production. So larger teams doing the construction and test and deployment activities. See, the below table has summarized the differences between these two stages. See, there is a life cycle aspect and engineering and emphasis, production stage emphasis. In the life cycle, that is the risk reduction, that is based upon the in engineering schedule and technical feasibility. In go for the production, it will be based upon the cost. Okay, so engineering stage, that will depend upon schedule, technical feasibility, and the production stage emphasis, it will be go based on the cost. And go for the products, architecture baseline, and production stage, the product release baseline. So in engineering stage, it will be based on the architecture. Here it will be form of the product release baselines. And activities, that is the analysis, design, planning is the engineering stage, and implementation and testing is the production stage. So the engineering stage and production stage will be divided into the two parts. So what are the in the life cycle of the aspect doing the engineering stage, and what is the life cycle of the aspect doing from the production stage? See, in the activities, go for the activities, the engineering stage has analysis, design, planning, and go for the production stage, that is the implementation and testing. And go for the assessment, that is the demonstration, like inspection and analysis, and go for the production, that is the testing. So go for economically resolving diseconomies of the scale. Here we can go for the exploiting the economies. So we can exploring the economically of the scales. And management, so engineering stage, these are the planning, and they go for the production, they operate the particular process. Okay, So these are the life cycle aspects are risk reduction, production, like products, activities, assessment, economics and management. These two are the depend upon the different of stages. These are the engineering stage and the production stage. In engineering stage, the risk is the schedule and technical, and production stage is architecture and activities, analysis and design and planning and assessment, demonstration, inspection and analysis, economicals and resolving, disconnection of scale and management is the planning. And production stage, the cost, product release basis, implementation testing, exploring to the economics of scale and operations. These are the two stages of the life cycle. See, the transition between engineering and production is a crucial event for the various stakeholders. So based upon the customer, these two are the different of our stages from the particular transition. See, the production plan has been agreed upon and there is a good enough understanding of the problem and the solution that all stakeholders can make a firm commitment to go ahead with the productions. Okay. In engineering stage, it is decomposed to the two distinct phases. There is inception and elaboration. So in the engineering stage, the both are, there is the idea and there is the initial stage, and design stage is based upon the engineering stage, and releasing and testing, everything will be dependent upon the product stage. So here whenever you go for the transition, it will be defined to the two stages. There is the engineering and production stage. In the engineering stage is the combination of inspection, like inception and elaboration. In the production stage, it will be based upon the construction and transition. Okay. See, and the production stage into construction transition, there is the four phases of the life cycle process are loosely mapped to the conceptual framework of the spiral model. See here, we can define the only four stages. There is the idea, architecture, beta release and production. See, in engineering stage and production stage, in engineering stage, inspection, like inception and elaboration. Go for the production stage is the construction and transition. See, we can go using for the different type of spiral models from the framework conceptually. It is the phase of the life cycle. This is the first one is the inception is an idea. There is a starting phase. In the elaboration is we can develop an idea that is based upon the architecture and go for the release, that is the construction, and go for the transition, it is a deployment phase. Okay, so if these are the, we have to divide into the four phases. There is the inception, elaboration, construction and transition. In engineering and production stages, it will be dependent on the two parts. That is the inception, elaboration is the engineering stage, construction and transition are the production stages. Okay, so what we say that in inspection is an idea, in elaboration is architecture, is the construction is the beta releases, in the transition is the products. This is the life cycle of the particular three phases, like four phases. Okay. See, inception phase, that is the starting phase of the particular process, like particular development. See, the overriding goal of the inception phase is to achieve concurrence among the stakeholders on the life cycle objectives for the particular. What are the objectives of the particular life cycle? It will depend upon the stakeholders. Here, the first one is the primary objectives, that is establishing the project software scope and boundary conditions. We can including an operational concepts, acceptance criteria and a clear understanding of what is and is not intended to the product. So what we have to using the product, what we are not using the product. So what we say that whenever we have to implementing the particular application, it will be including the operational concepts and acceptance criteria, and there is a clear understanding what we have intended into the product and what we not intend into the product. Okay, and second one, discriminating the critical use cases of the system and the primary scenarios of operation that will be drive the major design of traders. So whenever we have to design the scenarios, it will be useful to the, we have to implement particular major designs of the particular system. Okay, and next one, demonstrating at least one candidate architecture against some of the primary scenarios. So at least one architecture against some of the primary scenarios, and estimating the cost and schedule for the entire the project, including the detailed estimate for the elaboration phase. So in the elaboration phase, what we do, we have to estimate the cost and schedule for the particular project. Okay, there is a including detailed estimates for the particular elaboration of the phase. There is the to estimating the cost and schedule for the entire and estimating the potential. So what are the potential risks in the particular phase? So we can identify that at the stage of the first stage is the main thing. So first we have to, what are the use cases we are using, what are the conditions we are using, what are the requirements we have to assign, how to design the implementation, how to design, and how to, so we go for the from particular idea. So and also you can estimate the cost and schedule also, okay, and estimating the potential risk, that is the unpredictability. Next, essential activities, that is the formulating the scope of the project. The information repository should be sufficient to define the problem of space and derive the acceptance criteria for the end product. So what we tell is, whenever we have to implement a particular system, so what are the requirements are sufficient to the particular problem and how it will be derived from the particular acceptance of the criteria of the end of the product. So it is the main thing. So first we have to formulating the what is the scope of the particular project. In that, what are the requirements we have to assign to the particular system, okay. And next one, synthesize the architecture of the information. It may be to the processing of the, synthesizing the architecture, an information repository is created that is the sufficient to the processing, okay. The next one is and demonstrate the feasibility of at least one candidate architecture and an initial baselines of make by decisions, so that the cost, schedule and resource estimates can be derived. So next one is the planning and preparing a business case, alternatives for the risk management and staffing, iteration plans and cost, schedule, portability, and what is the trade-offs are evaluated. So everything will be planning to the particular project or particular product. So planning and preparing the particular business area. So what are the alternatives, risks in the management, what that may be staffing or iteration plans or cost or schedule or portability, everything will be evaluated in the particular essentials, okay. And next one is the primary evaluation criteria. See, do all stakeholders concur on the scope of the definition and cost and schedule estimates? So all the stakeholders, what will be then? So first of all, we have to define what is the cost and what are the schedule. So how to estimate? So these are the main thing, and our requirement understood as evidenced by the fidelity in the critical use cases. So what are the requirements? So our requirements will be understood or not, or the cost and schedule estimates, priorities, risk and development process and credible. So do the depth and breadth of the architecture prototype, it demonstrate the preceding criteria, okay. So it is the main thing of the primary value of prototyping candidate architecture is to provide a vehicle for the understanding the scope and assessing the credibility of the development program of solving, okay. And our actual resource expenditures versus planned expenditure of the accept. So what we say in the primary evaluation criteria, first of all we have to define what is the process is going on, how to estimate the particular system, what is the scope of the particular system, what are the process will be done, okay. Everything we have to assign. Next, elaboration phase. It is the second phase. So it's the end of the phase only, sorry. At the end of this phase, the engineering is concerned completely. That is, the elaboration activities must ensure the architecture and requirements and plans are stable enough and the risk sufficiently mitigated that the cost and schedule for the completion of the development can be predicted within the acceptable range. So within the acceptable range, it will be useful or not. So first we have to identify what is the process will be done and what are the process will be going on and how that process will be what are the risks will be sufficiently mitigated. And primary objectives, that is the baselining the architecture as rapidly as practical, that is establishing a configuration manager snapshot in which all the changes are rationalized and tracked and maintained, okay. And baselining the design, see, the baselining high fidelity plan for the construction phase and demonstrating that the baseline architecture will support the vision at a reasonable cost in the reasonable time, okay. Some essential categories are to elaborating the vision. So what is the vision? That vision we have to elaborate and elaborate the process and infrastructure also, okay. And elaborating the architecture and elaborating the selecting components. These are the main things of the essential activities, okay. Next one, primary evolution of criteria. So here, is the vision is stable, is the architecture are stable or not, and does executable demonstration show that the major risk elements have been addressed of the credibly resolved. So one executable demonstration, how that the major risk elements will be defined. Okay, is the construction phase plan of sufficient fidelity and is backed up with the credential base or estimate. So, and do all the stakeholders agree that the current vision of the can be met in the current plans is executed to the developer of the computer system in the context of the current architecture. So stakeholders doing that. So the given all the current plannings are executed or not, developed team will be doing the everything. So as usually the current structure will be developed or not. Okay, or actual resource or expenditures versus planned expenditures acceptable. So what are the resource expenditures are there, how to planning expenditures, so everything will be acceptable to the particular primary evaluation criteria. So everything we have to find. So it is the planning, what is the plan, how to back up, so execution plan or successfully executed or not, so current plan is be going or not, so what are the expenses that may be resource expenditures or planned expenditures, everything will be you can accept in particular primary evaluation criteria. Okay. Next, construction phase. During the construction phase, all remaining components and applications features are integrated. See here, when we go for the construction phase, we have to integrate all the modules. So what are the components are there? All the components will be integrated to the applications and all the features are thoroughly tested. So first we have to integrate and to test, everything will be working on it. So the newly developed software is integrated where required. So where it will be required, in that way we have to integrate to the different type of components. Okay. So the construction phase represents a production process in which emphasis is placed on managing resources and controlling operations to optimize cost, schedules and quality. Okay. And the construction phase, what are the primary objectives? That is minimizing the development cost by optimizing resources and avoiding unnecessary scrap and rework. Okay. So here we can optimizing the cost and what are the unnecessary reworks, everything will be we have to avoid, and achieving the adequate quality and rapidly as practical. So as practically we have to define the good quality and achieving useful version, that is the alpha version we have to release or beta version or other test releases as rapidly as a practical. So what are the essential activities? That is the resource, maybe resource management or control or process estimations and complete component development and testing against evolution of criteria. See, when we go for the assessment of the product releases against acceptance of criteria of the version, these are the essential activities from the construction phase. So inception, so it is the idea, elaboration is the architecture, and go for the construction. We have to integrate all the what are the components we have implemented. These all are the components will be integrated and to have to test that one. If it is required, we have to test the particular components. Okay, and also we have to integrate it where it will be possible. So where it will be available. In that way, we have to integrate to the all the components. Okay. Next, primary evaluation criteria. See, is this the product baseline mature enough to be deployed in the user community or not? So there is the existing of some of the defects are not abstractable to achieve the purpose of the next release. So what are the defects in the existing system? That existing defects we have to take and then we have to solve in proposed systems. Is the product baseline stable enough to be deployed in the user community or not? That is the pending changes are not abstractable to achieving the purpose of the next releases. Okay, and are the stakeholders ready to transition for the user community or not? So all the stakeholders ready for the that is a deployment possibly start or not, or actual resources expenditures versus planned expenditures are acceptable. Okay. Next one is the last phase, that is the transition phase. It is the deployment phase. See here, when we go for the transition phase, the transition phase is entered when a baseline is mature enough to be deployed in the end of user domain. This typically requires that is usable subset of the system has been achieved with acceptable of the quality levels and user documentation, so that the transition to the user will provide the positive results. So everything will be perfectly deployed for and the end user, that maybe give the positive results. If any problem will be occur, that may be quality, that may be feature of the product, so it will not give the positive results. So everything will be perfectly deployed. The user will give to the positive results. So this phase could includingly of the following activities. The first one is the beta testing, is to validate the new system against user expectations. Next one is the beta testing and parallel operations related to the legacy system it is replacing. And next one is the conversion of operational databases. Here there are totally 4 phases. First is the inception, elaboration, construction and transition. So inception is the starting stage, elaboration is the architecture, construction is the to development of the particular systems, that is the what are the components we have developed, what are the components will be you have to integrated. So in the how to test, everything will be from the construction. And go for the transition, we have to take some of the baselines and we have to release to the product in the end user. So it will be effect to the particular system, to the user, they give to the some of the positive results. So this phase, okay. And also it will be include the different type of activities. The first one is the beta testing to validate the new system against the user expectations, and beta testing and parallel operations related to the legacy system it is replacing, and conversion of operational databases. These are the 4 phases, that is the inception, elaboration, construction and transition. See, the transition phase concludes when the deployment baseline has achieved the complete vision, that is the different type of primary objectives, that is achieving user self supportability or not, and achieving the stakeholder congruence. The deployment baselines are complete and consistent of the evolution of criteria, and achieving the final product baselines as rapidly and cost effectively from practically. So everything will be due. So self supportability and evolution of the particular baselines, and finally we can use the cost effectively from the particular system. And go for the essential activities, that is the synchronization and integration of concurrent constructions increment into consistency of the baseline development. So it will be deployment the baseline, that is the cutovers, the commercial packaging and production, like the sales roll out kit development, field personal training. So whatever maybe it will be developing, it will be based upon the deployment specific engineering. So and go for the assessment, that is the assessment of deployment baseline against the complete vision and acceptance criteria in the requirements of this set. So how the evaluation of criteria, that is if the user are satisfied or not, that is the main thing of. So if the user satisfied or not, and are actual resource expenditure versus planned are acceptable or not. So the expenditure కూడా ఎక్స్పెక్ట్ చేయగలరా లేదా అని కూడా మనము యాక్సెప్టబుల్ కాదనేది చెక్ చేస్తాం. ఓకేనా, దీస్ ఆర్ ద ట్రాన్సిషన్ ఫేజ్. Next, artifacts of the process, that is the artifact fact set, that is to make the development of a complete software system is manageable, and we have to distinct collection of information organized into the artifact sets. So we have to collect different type of information. So why we have to collect different, we have to implement a particular system, we want to the different type of information to organize into the artifact set, and artifact representative to the heavy information that typically is developed and reviewed as a single entity. Okay, and lifecycle software artifacts are organized into 5 distinct sets that are roughly partitioned by underlying the languages of the system, that is the management, requirement, design, implementation and deployment. So these are the main 5 artifacts of the to implement of the life cycle of the software. See, the life cycle software artifacts are organized into 5 distinct sets that are roughly partitioned into underlying languages of the set, that is the management, that are the textual format, requirements, model of the problem space, design, that is the human readable programming language and associated source, and deployment, that artifact set are shown in the below figure. Okay, so these are the main 5 artifacts. First one is the management, requirement, design models, implementation and deployment. So these are the 5 artifacts of the particular life cycle of the software development. Okay, next, Thank you, ma. Go for the next class.